All right, so the final video for this section, section 3 on redox reactions, all culminates here. So example number 6, we're going to put it all together. So what is oxidized and what is reduced? And what is the oxidizing and reducing agent? So this is just like a question that you could get on the exam. So let's put it all together and you can see how it all works out. So you have a reaction, chemical reaction here. It's balanced. We need to answer what's oxidized and reduced, as well as what is the oxidizing and reducing agents. In order to figure out what is oxidized and what's reduced, we need to know what the charges are, or what the oxidation numbers are. So what we need to do is we need to go through every single substance in the chemical equation and assign oxidation numbers based on those rules that we've learned. Now, hopefully you'll see it's not as crazy as it actually seemed like when we first looked at it. So taking a look, first of all, I want to point out the coefficients aren't going to make a difference, so you can ignore those. You're just going to go through and look at the substance itself. So iron is an element that's by itself. It's a neutral element by itself, so it is going to be 0. Now we have HBr. HBr is a compound, so ask yourself, do we know a rule for any of these? We do know a rule for hydrogen. Hydrogen in this case is going to be +1 since it's not a metal hydride. And therefore, what is the oxidation number for bromine? Bromine has to be -1 because HBr is neutral. On the product side, we have H2. Okay, H2, remember, be careful with this one. H2 is just the element hydrogen. It just happens to be 2 because it's diatomic, but it's the element hydrogen, right? So that's going to be 0. Any element by itself is going to be 0. And then we have FeBr3. We actually don't know a rule for either Fe or Br3, and so we kind of default to the rule of whatever the more electronegative element is, gets to keep its normal oxidation number. Bromine being the more electronegative element, that gets to keep its normal charge, which since it's a halogen, it's going to be -1. Using a little bit of math here, if bromine's -1 and there are 3 of them, and there's 1 iron, iron must be +3. Okay? And so now that we've done that, now we can look from the reactant side to the product side, what's changing? Notice iron went from 0 to +3. So iron's charge went up. And so if its charge went up, what does that mean? Was it oxidized or was it reduced? The answer is it was oxidized. And so I would put down here, iron was oxidized, Fe. Okay? Hydrogen went from +1 down to 0. So hydrogen's charge went down, right? And so that means it was reduced. Notice in this example that bromine was -1 on the reactant side and -1 on the product side. So bromine was spectator, was not part of the reaction at all, kind of like how chlorine was originally, or in the previous example. All right, so now when we go to figure out which one's the oxidizing agent, which one's the reducing agent, remember, it's just the opposite. That's the easiest way to think about it. So iron was oxidized, and therefore it's the reducing agent. But always ask yourself, how was iron written as a reactant? And iron was written just as Fe. So iron was oxidized, therefore iron is the reducing agent. Hydrogen was reduced, therefore it is the oxidizing agent. But how was hydrogen written as a reactant? It came in the form of HBr. So I have to make sure I write HBr as my oxidizing agent. Let's do one more example. Let's look at the second one. So we need to go through first, we need to assign oxidation numbers to everything so we can figure out what's oxidized and reduced. So nitrogen is an element by itself. It's diatomic, but it's still just a neutral element, so it's going to be 0. Same thing with hydrogen. It's a neutral element, so it's also going to be 0. On the right side, the product is NH3. We do know a rule for hydrogen, and so hydrogen is always +1, except in metal hydride examples. So it's +1. And if I do a little bit of math here to figure out what the oxidation number is for nitrogen, nitrogen is -3. And so now looking at what happened, nitrogen went from 0 down to -3. You see that? So nitrogen's charge went down. So nitrogen was the one that was reduced. And then hydrogen went from 0 to +1. So hydrogen's charge went up, and therefore hydrogen was oxidized. So once again, notice when I'm just filling out oxidize and reduce, I'm just identifying the element. I'm just saying, hey, hydrogen and nitrogen. I don't have to worry about the formulas or anything like that. It's just identifying what element's charge went up and down. But when I go to figure out what the agents are, that's where you have to watch and make sure that it's written correctly. So hydrogen was oxidized, therefore it's the reducing agent, but specifically it came in the form of H2 as a reactant. and nitrogen was reduced, therefore it's the oxidizing agent, but nitrogen came in the form of N2 as a reactant. And so that concludes redox reactions. Make sure that you do some practice with this. We do have some worksheets that are available to you in Canvas, but if you need more practice, you can always look in the textbook. You can also look online. Just go to Google, search for redox reaction worksheet or something like that, and you can find a lot of practice out there. So make sure that you feel comfortable with redox reactions. I'll see you in the next video when we start section 4.